Okay. I'm afraid I'm going to run out of recording time because it's not, yeah, it can only like store so much or something. I just upload everything to YouTube and it's saved there, so I just delete it off of the folder, but it didn't look like it was working right. I mean, everybody's here today, so it's not the biggest deal, but, alright, so, we are going to start looking at some word problems that will be generally easier to use substitution on, not substitution, elimination on than others. So this first problem is just like a purely theoretical problem that math teachers come up with for you to practice this. It's not really an application problem, but we'll get to some that are application problems. So it tells us the sum of two numbers is 71. Their difference is 125. Okay? What's that tell you? If their sum is 71, but their difference is 125, I think a negative is going to be involved because usually when we add two numbers together, it's bigger than if we subtract them, right? So I think one of our numbers is probably negative, and that's why this is happening, that this is bigger, but we'll find out. So so we want to know what is the product of the two numbers. So we have two numbers we need to find. We do not know what either one of them are, so we could give them any variable name we want, but typically we like x and y, right? So for these problems, you're going to have to write two equations based on the information you have. So this first sentence gives us one equation. The sum of two numbers is 71. So, Rosalind, what could we write for that equation if our two numbers were x and y? What does sum tell us to do? Add. So, sum of two numbers, we don't know what the numbers are, so we're just going to call them x and y. So, x plus y. Rosalind, what does is tell me to write? Equals, and then 71. Okay, so that first sentence tells us to write this equation. X plus y is going to equal 71. Okay, so then we see their difference is 125. That's our second piece of information. So, Lexi, what does difference tell us to do? Good, so what's that going to look like for the second equation? Okay, difference tells us to subtract. So if we're doing the difference of two numbers, it's going to be x minus y. Or you could do y minus x, really. They didn't tell you which one was the bigger number here, right? So it doesn't matter which one you do there. And that will equal, because it is 125. Everybody okay with setting up those two equations? Now, the nice thing about this is it's ready to go for solving elimination, right? All we have to do is add these together. Our y's are going to cancel. So this is what we did on Thursday and Friday, Haley. We've got two equations, and they are in standard form. So we've got our x and our y on the same side, and then it's going to be equal to a number over here. And our goal is to add these together and have either the x's or the y's go away. So this one is a really simple one, because if you add them together right now like they are, x plus x gives you 2x, and the positive y and negative y will cancel each other out. And then we'll just add these together, so we will get 286. Sorry, I don't know what I'm thinking. I don't know why I think I got something slid over or something there. 196. I was way off. So we're just adding 71 and 125. Alright, then, Haley, that's a really simple equation to solve. So what can we do to solve that equation if we got 2x equals 196? divide it by 2. Good. And for these, I will allow you to use calculators on these because you should be getting bigger numbers. And what do we get whenever we divide there? 98. Okay. And just like we did with substitution, once we have one of these numbers, we can just plug it back into either one of the original equations. It doesn't matter which one. So if I use the top one, that 98, I'd put 98 plus y equals 71. Or you could use the bottom equation. It doesn't matter which one you want to use. And then if I'm solving that, Haley, what would I need to do to solve that equation right there for y? How would I get this y by itself right here? Very good. I'll subtract that 98. And whenever I do that, my y is going to be negative 27. Yeah. Okay, so 98 is my x coordinate, negative 27 is my y coordinate. Okay, questions? Okay, so this actually happened a few years ago, but they didn't quite have the right information for us to figure out. So for the senior play a few years ago, they knew they knew how much money they had made, and they had also counted the number of people there, and they were wanting to know the number of adult tickets and the number of child tickets. The problem with that is that there were a lot of people there who had not paid because they got in free for whatever reason, so their total number of people there was not correct. Like, all the people there had not paid. So they had asked Miss White was here at the time, and they had asked her about it, and we could have figured it out if we knew only the people that had paid, but they had just counted the number of people in the seats, and that included several people that did not have to pay for whatever reason. So we couldn't get the exact correct answer. But you can imagine that this could happen, so lots of places are going to charge differently for either students and adults, or maybe sometimes it might be for adults or senior citizens or something like that, have different prices. So senior play student tickets only cost $4, but adult tickets cost $7. Ticket takers know that they made $726. That is very easy to come up with because you count your money at the end of the night, right? You know how much money you have. And that 126 people attended. So that is also pretty easy to count, as long as you don't have people there that did not pay to get in like we had that particular time. So as long as everybody that is in there actually paid to get in, then you can just count the number of people that are there, and you will know your total attendance. But they forgot to count how many tickets were student tickets and adult tickets, so they didn't keep up with how many of each they had. And they would like to know how many of each type of ticket that they sold. So systems of equations can be used to figure this out. So our question says, how many of each type of ticket did they sell? So that tells me what my variables need to be. Okay? The number of student tickets should be one variable, and the number of adult tickets should be the other. You may use X's and Y's here. However, I would suggest, if possible, if it's not a really terrible variable, using a letter that reminds you what you're looking at. So I'm going to use S for student tickets and A for adult tickets. So we're going to write that down. S is number of student tickets and A is number of adult tickets. I don't really like S as a variable. It's kind of bad. But it is nice at the end, whenever you get S equals 12, you remember it's student very well. Whereas if you do X and Y, sometimes you might get them mixed up. Now, Henry is starting to get better about this. But whenever you write these equations, I usually tell my students that you need to write one equation like your Henry and one equation like your Hunter. Henry is my littlest one. Hunter is the oldest one. Because if any of you have been around small children like 4 or 5 or under, they can be easily tricked with money because they do not understand the value of money. So like Henry just had his birthday party Saturday, and somebody gave him a $100 bill, and he was, Hunter was trying to trick him, and he went and got like 5 $1 bills and was trying to trade him the 5 $1 bills for the single 100, and he did not fall for it. He knew 100 was more, and he told him no, which, I mean, I wouldn't have let him do it anyway, but I was proud of him because he understood that the $100 was worth more than those 5 $1 bills. 2 years ago, he would have fell for it for sure, because little tiny kids do not understand the value of money. They understand how to count the number of pieces of paper that they're looking at, right? Or if you have coins, you can trade a 3-year-old $2 for their $100 bill just about every time, because they think 2 is more than the single $1 bill that they have. So, what you're going to do for this equation is you are going to write one equation where you care about the value of each one, and the other where you do not at all. Hello, dear. You can bear to take your stuff with you when my door's shut. Go on. Get to class. Okay. So let's write our first equation where we care about the value of each one, right? So student tickets cost $4, adult tickets cost $7, and I know they took up a total of $7.26. So $4 student tickets would be 4S, and adult tickets are $7, so we'd have plus 7A. Okay, so make sure you write this down. And that equals the total amount of money that they made, which was $7.26. Okay, make sure you're writing the equations too, because sometimes I'm not even going to ask you for the answer. I'm just going to ask you to set up the equations. And they do that on the exam also. All right, so that considers how much the value is. Now, the 126 people, when they count the 126 people, does it matter whether they're children or adults? Or are they counting them any differently? No. One of them doesn't count more than the other, right? So if we want to know the total number of people, $4 and $7 is not involved here, right? S is our number of student tickets. So we would say S, that's the number of students that are there, plus A, that's our number of adults. So students plus adults should give us the total, right? So we should just have S plus A equals the total, which is 126. All right, is everybody with me here on setting up this equation? So, so the first considers the value, the second does not. It's just number of people. Okay, so we now have this set up we want to solve. You can use any method you would like to solve. You could use substitution if you want. You'd have to solve one of these equations for A or S. I think elimination is a little bit easier for this. So let's see. Anya, would you like to get rid of the S or the A? S. Okay, so if we're going to get rid of S, what do we need to multiply that bottom equation by? -4. Very good. So we'll multiply that bottom equation by -4. So, Haley, we are choosing -4 because we want to have, we already see we have a +4 here. If we multiply the bottom by -4, it's going to cause those S's to go away. So, and we just chose S's because Anya told me to choose S's. We could have done A's pretty easily here by multiplying by -7. Okay? So, when we multiply, the top equation is going to stay the same. The bottom equation is going to be -4S minus 4A equals, and we're going to use a calculator on this one. 126 times -4 is going to be -504. Everybody okay here? Okay. Same as what we've been doing. You're just more likely to get some decimals and things that don't come out quite as nice sometimes with these. So these will cancel. 7 plus -4 is going to give us 3A. And then we'll do 726 minus that 504 is going to give us 222. And then last step right there, divide by 3. So A equals 74. So that's 74 adult tickets. Okay, any questions there? Now, it asks for how many of each type, so we also need to know children's or student tickets. Well, what can we do to find that? Plug in. Bottom equation is easier to plug into. So, S plus 74 equals 126. Subtract that 74. So S will equal 52. So 52 student tickets. So those together would be our answer. Whenever you're given a quiz on these word problems, it's more likely only going to ask you for one. Oh, I messed up on the last problem. Let me go back to it. I messed up. We gotta look at it. It's more than likely only going to ask you for either adult or student tickets, not both in this case. Caitlin? Saw something fly. Should not. Thanks.